We're back. If you haven't seen part one, this is probably going to be pretty confusing, but this is a prototype remote control log skidding robot that sat in a barn for 10 years. We got the engine running, but it had a massive fuel leak and some dodgy bare wires. So we're going to dial back the sketchiness and see if we can get the engine kind of sorted out. And then we will dial up the sketchiness and hack into the wiring system and see if we can get the various hydraulic functions to work. I've got some parts straight from the HOTS mothership. There's a fuel filter. A return line, a supply line, and all the various copper washers and seals that we need. This stuff is not cheap. There's just over $400 here for those basically 3 parts. Boy, this thing is really crusty. Stupid rodents. The only real leak is up on the top, and a couple guys told me that this is a common problem with these engines and the Deutz engines too, and that all you really need to do is chop apart the crimp and then install just some basic rubber hose with a regular hose clamp, which seems like a good idea, but fortunately I already ordered the parts before I knew that, so we got them, we might as well put them on. Okay, there's one. Not 17. Okay, come on. There's that one. Boy, it was not long for this world. Look at that crimp. Just completely rotted out. Rodents. I hate them. Oh, there's a clipped off wire. I wonder what that was for. Looks like a pretty big one too. Going into that relay, I think. Okay, well, we'll get the fuel system sorted out first, and then we're going to have to tear into the electrical because it's looking pretty shoddy. I don't know if that's coming out of there. Really? We're gonna get all the way there and then we still can't get it through because of the banjo fitting? There. Well, I don't think anybody really has a good system for doing these return lines, but this is amongst the most complicated ones I've seen. 3 copper washers and a spacer, and one of the copper washers is a different size than the other 2. Okay, yeah, everybody had their own idea. My Oliver tractor, that one's super complicated. It's got actual T's and compression fittings. You got to bend the lines up in like a figure 8 to make them work. John Deere had those pot metal tees with the kind of square rubber washers that you had to smash down. And they had just straight steel lines between them. Those work pretty good, I guess. And then this attaches there. Okay. Cool. I gotta work that grommet back down in there, but otherwise I think we're done up here. The lines are installed. Let's go ahead and see if we can get this fuel filter off. I think she's been on there a while. The rodents, they really did a number on it. I hope we don't find any more problems related to them. They're so destructive. Some of you guys might remember I had a Honda Civic in here that we worked on that sat in a pasture for, I don't know, 5 years or something. And the mice got up underneath of the alternator, between the alternator and the engine block, I believe, built a nest, and they peed on that thing so much they swelled up the case of the alternator and essentially seized it up. Okay. There's a mechanical lift pump here. Should be able to just pump that and see if we have any leaks. Oh, I hear it. Okay, I think that's it. I can hear it running through the return line back to the tank. So we should be good to go. But we got to do something with this wiring. This is a hot mess. So that big wire there is just broken off. Looks like maybe the terminal broke off. I don't know. I think it goes into the bottom of this relay. I don't know what that does. So I'm going to have to see if I can find a wiring diagram, and we'll see if we can fix that up. We've got a chewed up wire here and a broken off wire here. Those both go into this relay socket, and the relay itself is also in pretty crusty condition. So I'm going to go ahead and replace that with a new relay socket and a new relay. I think there's one other wire I saw that was gnawed on up by the alternator. Should be pretty straightforward here. Of course, a smart person would probably disconnect the battery. Well, what's the worst that could happen? Crusty. All right, I think that'll work. Now there's one more wire way up yonder. I'm going to have to patch up. I think I'll just put some liquid electrical tape on that for now. And then once we find out that the alternator doesn't work and I have to tear that all apart, I'll go ahead and fix it right at that time. I think we should be able to fire it up and make sure there's no leaks. Maybe run it for a few minutes, get it slightly warmed up, and then we'll change the oil. So let's see what happens here. The good news is it runs, and it's not leaking from the new hose, but it's still leaking a lot of fuel somewhere. I think somewhere in the injector. So we may have to pull this number 1 cylinder injector out and have a look at it. I don't know what's going on. Yeah, maybe it is still coming from up here. Well, there's your problem. So I somehow pinched that copper gasket when I put it back together. That'll work. Should be a pretty easy oil change. There's just a valve here with a hose that sticks out the bottom. If it'll actually drain, there it goes. Well, according to the chart, you can put just about any oil you want in this engine, but it seems to be happiest with 5W40. So that's what we'll use. I think we've sufficiently dialed back the sketchiness on the engine. I'm going to leave the tin work off for right now because I want to pressure wash inside here. I don't know if the alternator works, but it doesn't really matter. Let's move on to the hydraulics. A lot of the hoses were disconnected. I think I've got them all hooked back up or bypassed. But the problem is, to get the hydraulics working, we have to deal with the electronics. That's where it gets kind of complicated. Trademark drawing time. This is an overview of the hydraulic system as I currently understand it. And there's a lot going on here. The engine powers 4 separate hydraulic pumps. The first one is a hydrostatic pump that powers the right side track motor, and it's controlled by a proportional electric solenoid. So proportional basically means variable or analog, if you like. The more current we jam into that solenoid, the faster the track motor will spin and the faster the machine will move in a given direction. There's a second identical hydrostatic pump here for the left side track motor, and it's controlled the same way. Between those is a third hydrostatic pump that powers the winch. And instead of a proportional solenoid, it actually has this tiny little hydraulic cylinder that moves a control lever. And I'm not sure why they did that. There's also another tiny hydraulic cylinder that controls the throttle. At the back is a fixed displacement vane pump or gear pump, and it powers all of the other hydraulic functions, the blade, the arm, the grapple, and those functions are controlled by on-off electric solenoids in a bank here and then kind of spread throughout the chassis. So one for the throttle, winch, the free spool, which I believe I called the brake in the last video. It's actually a free spool. There's one that's not used as far as I can tell. Blade, arm, and grapple. The grapple also has an accumulator. So it's basically it stores pressure so that when the grapple is clamped onto a log and you let off on the hydraulics, it will maintain its clamping force on the log. Yeah, so what we have to do is hack into the controls and fire these solenoids and see if we can get this thing to work. And if we can get it to work, then we'll build an actual remote. I don't know why, but I just really don't want to hack this machine up. It's going to be like that movie Armageddon, where Bruce Willis and his buddies start tearing apart this multi-million-dollar NASA space rover, throwing parts out of it. Pretty soon there's like a small block Chevy crankshaft on the workbench.
First of all, you got the flow system all reversed.
That's right.
Well, that's because your cams are all wrong, Mr. Wizard.
Oh well. If we want it to work, it's got to be done. Alright. It's done now. Now the sketchy part. I'm going to put power to the solenoids manually, one at a time, and we'll just see if we can make it move. In an effort to not die, I'm going to use this remote starter switch and kind of stay at a safe distance. See if we can hear it clicking. Yeah. Okay, so let's fire it up and see what happens. Alright, it's not working. Well, shucks. I had this delusion that I could cobble together a remote and drive this thing around and kind of show it off and put a nice bow on it for Christmas. That is not going to happen. The good news is the engine fires right up, it doesn't leak, and it purrs like a 2-cylinder kitten. The other good news is the tracks seem to work. They're pretty crusty and crunchy, but they do turn. The bad news is none of the other hydraulics work. And I don't know exactly why. I don't have a schematic. I kind of made my own schematic, and if I'm looking at it right, there is no way that the hydraulics can work the way that they're currently configured. It probably looks like gibberish to most of you. Don't feel bad. This is very confusing. I barely understand it myself. As it's drawn, I don't think this system can possibly work. And in practice, it doesn't work. None of the circuits fed by this pump work. I get a little bit of flow, but they will not build pressure. And I don't know if I've got something hooked up wrong, or if this is designed wrong, or if something's broken, or if my brain is broken, and I'm thinking about this all wrong, but I don't see how this can work. So there is a fixed displacement gear pump that feeds a parallel manifold, and there are 5 electric solenoid valves. 4 of them are closed center. This one here, for all intents and purposes, is a closed center valve. This one is not used. The ports are blocked off. This one for the grapple has an accumulator. This one for the free spool has 1 port blocked off. This is a single acting cylinder, basically. But everything else is just regular hydraulic cylinders. Standard stuff. But what's weird is that this valve here for the blade is a tandem center. So anytime that this is in the neutral position, the pressure can go right through this bypass and back to the tank. So with this in the neutral position, none of these circuits can possibly build pressure. But what's weird is that this one doesn't work either. If I actuate this valve, the blade will not go up, it will not build pressure. So I don't know how this is supposed to work. They're mixing
closed center and open center valves. And I would expect this to be set up as open center. So these should all be tandem center, and the pressure should go through each valve in series. But they have them set up in parallel, which is how you would do it if it was closed center. So I don't know how that can work. There's no load sensing valve, unless they're just deadheading it and running it past the relief valve all the time, but that, I don't think that would be the case. That'd be pretty inefficient. So I don't know. This is very strange. As far as I can tell, none of this stuff has been monkeyed with. I mean, the solenoid valves are all in their original positions. The plumbing is in the correct positions. I don't know. This is beyond my abilities, I think.
Luckily, there's a lot of really smart people who watch these videos. I don't know exactly why, but they do, and they help me, and that's what I need. I need somebody who knows more about hydraulics than me to tell me what's going on here. Yeah, I really thought the controls was going to be the big challenge, and I've more or less figured that out. I didn't expect the hydraulics to be a stumbling block. I thought we could just tap into them and make this thing work. Sadly, that is not the case, but that's okay. I'm out of time. Thanks for watching. Merry Christmas, and we'll be back with part 3.